The National Blood Culture Survey results performed at the end of 2018, the beginning of 2019. We believe this to be the first national blood culture survey to be performed globally. A smaller survey was conducted 4 years ago. This was a telephone survey involving 43 laboratories, and since then there have been definite improvements. In this survey we had 158 responses, and this was where they were from across the UK. Majority were from district general hospitals, and of the responses 124 had an on-site microbiology laboratory. But before going into detail of the results, I want to give some background as to why blood culture results are important. In patients presenting at the front door with sepsis, the clock starts. We have an hour to perform the sepsis 6. During that time, blood culture should be collected, and the patients normally started on broad-spectrum antibiotics. Once this is completed in the hour, time seems to be less important. The patient will be transferred to the ward, and it takes at least 24 hours to see whether the patient is improving. However, there is one thing which may make a difference in that 24 hours, and this is the blood culture results. And if completed in an optimized pathway, many positive blood culture results can be turned around, that's from collection to issuing results, in less than 24 hours. And what is the impact of having rapid results? This is extracts from a recent paper from Clinical Microbiology Reviews from the American Society for Microbiology in their series Clinical Microbiology Best Practices. And what they say is that rapid identification of bloodstream pathogens is a laboratory practice that supports rapid transition to directed, targeted therapy, leveraging results to support timely and effective patient care. Up to 40% or more of patients may not be on effective empirical antibiotic therapy. This is likely to get worse as antibiotic resistance spreads. But rapid results have multiple positive impacts on patient outcomes, including reduction in mortality, reductions in morbidity, hospital lengths of stay, antibiotic use, and healthcare expenses. So the blood culture can make an impact on patient care in the first 24 hours. And it's also important because it provides a clue to the source of infection. When patients come in, they are often transferred rapidly through a series of teams, and nobody questions the initial diagnosis. And often this may be wrong. For example, a patient is labeled as a chest infection, but as soon as you get the blood culture result with gram-negative rods, this suggests that the focus is elsewhere, often the urinary tract. They also prompt further investigations and have infection control implications. And the other thing to say is blood cultures are broader than just sepsis. Blood cultures are collected from a much wider group of patients, but if they are not managed correctly in a timely manner, they have the potential to become the sickest in the hospital from the point of view of sepsis. So this slide is just to explain why often the pathway for blood cultures is not optimized. For blood science tests, clinicians know these should be turned around within an hour, so they have a peg to hang their hat on. Blood cultures are very different. Because of their innate biological variability, nobody knows if a blood culture becomes positive, but if it does, it can over a variety of times. And without audit, because of this, one is unable to know how well the blood culture pathway is functioning. So audit is key. But it goes further than this. If you're a clinician and there are delays in the pathway and you're unaware of them, you cannot match the impact of a delay result may have on patient care. But in some high-profile deaths, here the coroner in Ireland was able to see that the blood culture pathway was not performing efficiently. So if we go back to the National Blood Culture Survey results, we'll ask the laboratories if they'd audited the blood culture pathway looking at the critical time points. 3% had monitored had actually audited this more than 2 but less than 3 years ago, 13% a year but less than 2 years ago, and 43% within the last year, and roughly an equal number had never audited the pathway. When you looked at the 41 hospitals, laboratories providing to off-site hospitals who had no laboratory, less than half had actually audited the pathway. Although half claimed to have audited the pathway, only 32 hospitals were able to give data on the percentage of blood cultures which were loaded within 4 hours of collection. The target should be 100%. 2 of the 24-hour laboratories managed to load 100% of their blood cultures within 4 hours of collection. But you can see the median for others was 35%, but ranging from less than 10%, as we've already said, to the few laboratories which were performing 100% within 4 hours of collection. Out of the 24-hour laboratories, it's worth noting that whilst 2 completed 100%, the others varied from 11% to 96% within 4 hours. When a full data set was required, only 16 laboratories, the 3 laboratories which loaded 100% in 4 hours are not included here, only 13 laboratories could provide complete data sets. The first thing to notice is just under half of these, some specimens are taking more than 24 hours from collection to being loaded on the analyzer. As you can see in hospital number 12, more than 50% take between 12 to 24 hours before they're loaded onto the analyzer. 3 of the ones which could not complete, the ones which had specimens taking more than 24 hours, only 3 of these may have been from hospitals off-site. So at least 4 of these actually were from samples collected on the same site as the laboratory, were actually taking more than 24 hours to reach the analyzer. Hospitals were also asked the last time the blood culture was actually removed from the analyzer during the working day. And you can see that during the working week this varied from 2 o'clock to up to midnight, but at bank holidays and weekends this changed, with a number of laboratories stopping work at midday. So if a blood culture signaled positive just after midday, it could sit on the analyzer for potentially 21 hours before being removed. This data is from laboratories which provide a routine working service during the day and only an emergency service out of hours. Out of the 24 laboratories operating 24 hours a day, 3 of the laboratories were not processing blood cultures outside of what they called routine hours. So they weren't providing a true 24-hour blood culture service. What happens to blood cultures received in a laboratory outside of routine working hours? Ideally, the manufacturer says they should be loaded on the blood culture analyzer, but the alternatives, they're placed in a standalone incubator or they're left lying at room temperature. And this is the breakdown across the 3 different types of storage. Ideally, they should be placed on the analyzer. If they're placed in a standalone incubator, if they're left in there too long, certain organisms may go through their growth cycle because they do not produce enough acid. When they're placed on the analyzer, it will give a false negative result. But even leaving all blood cultures at room temperature, a recent paper from Italy shows that for every hour a blood culture does not delayed getting on the analyzer, 0.3% of positives will be lost. The analyzer is optimized for the actual incubation of blood cultures. Not only does it rapidly get it up to temperature, it mixes the ingredients, and in some analyzers the mixing of the beads, the resins in there, lyse the white cells, releasing the intracellular organisms. In some hospitals they've actually set up satellite blood culture analyzers in the emergency departments and neonatal unit to actually facilitate loading the blood culture rapidly on the analyzer. And as was said, this is a gold standard. This is where blood cultures should be located. Blood cultures can either be made out of glass. The drawbacks to glass bottles is they can't be placed into the air tube delivery system. Plastic can, there is a slight difference in cost. Plastic slightly more expensive, but most of the extra cost is gained because it is cheaper to dispose of plastic bottles because they're lower weight. So much of this is returned in other areas. Ideally, people should be collecting 2 sets of blood cultures, but as you can see in the UK, in some sites only collected 1 aerobic bottle in adults. The majority of sites collected a single set of blood cultures, and only 2 sets were collected on 17 sites. And one hospital said that while it was recommended for 2 sets to be collected, in practice only 1 set was collected. So national standards should be for 2 sets to be collected, and there's very good information showing that the volume of blood cultured is directly proportional to the positivity one obtains. Laboratories, after they ordered blood culture volumes, the vast majority of people didn't audit it. Where some laboratories had audited it, the percentage correct fill varied from 8% up to 98%, but the majority being suboptimal. Some sites had actually done some initiatives to improve this. There was one very good simple study done by Gemma Windsor at Heart of England Trust. The new analyzers will measure the volumes of blood automatically. They fed this back to different groups in the hospital and gave some education. The average volume per bottle, which should be between 8 and 10, was less than 5 mils. Through education, this increased to 7.5 mls, and increasing the volume by 2.5 ml, they were able to increase the number of significant positive blood cultures by 50%. There is much more data to come out of the national survey, but this is just preliminary data to show what could be done to improve the pre-analytical phase of the blood cultures, and that's getting the correct volume of blood, ensuring the correct number of sets and adequate filling, and getting them out onto the analyzer rapidly will have a substantial impact on improving the blood culture pathway. If you have everything in place, so you've got the correct type of blood culture bottles, plastic, you have a pneumatic air tube, you have a centralized reception with microbiology linked to it, and 24-hour shift system in blood sciences, then it should be easy to load 100% of the blood cultures within 4 hours. So here, these are from the sites. We had 123 laboratories, 109 used plastic bottles. Of these, in terms of an air tube, some delivered purely to microbiology, but 97 delivered to a centralized reception. 69 had microbiology connected to that, and a similar number, 65, had a 24-hour shift system in blood science laboratory. So they had all the credentials. If everybody knew, if the clinicians, people taking the blood cultures, were told to send the blood cultures without delay, and they could utilize the blood science people who work 24 hours a day shift system, so it shouldn't be an extra cost. It's very quick to load onto a modern analyzer. So 65 sets without any further expense should be able to load 100% of their blood cultures within 4 hours, 24 hours a day.